Hey everybody, it's Ben here coming at you from my home office slash spare bedroom. Right now I'm working on converting a tractor to electric, so you'd think I'd be out in the garage. But unfortunately, there's been a few challenges to this project, including the fact that with the whole coronavirus situation, safer at home, lockdown, quarantine, all that, it's been hard to get materials. Also, there's a lot of places and resources I'd normally use that I can't right now. For example, if I wanted to do some machining, use a lathe or a mill, normally I'd do that at the Milwaukee Makerspace, and I can't do that right now because they're closed. So I thought what I would do is kind of some virtual machining. So I'm going to show you how I'm doing that right now in some 3D software. Corona hair, don't care. My 9-year-old gave me a haircut, so please enjoy that. Let's take a look at the software. So here I'm using a program called Fusion 360. This is a program by Autodesk. I started playing around with this a little while back. It's free to use for learning on, just for personal use. And it's got a lot of really cool features in it. So all I did was I walked myself through a few tutorials on YouTube. And what I really wanted to do to start with was just model the end of the crankshaft from the engine, because this project is going to reuse the flywheel. So this represents the part on the tractor, on the crankshaft, that held the flywheel. Now, it's pretty straightforward. It's just a disc, a flat cylinder with a couple of holes through it. So all I did was I just measured it with my digital calipers and laid it out on the computer. Pretty straightforward. Now there's some cool things about the software. So for example, you can model threaded holes right in it, real simple. I did take a not-for-credit machining class a couple years ago. We literally programmed CNC machines using text editing, just manual G code. So it was kind of fun to learn about, but was neat when I was working on modeling these holes with the dialogues that popped up. I'm like, wait a minute, I understand this, which was kind of a cool feeling. So obviously I'm a very amateur machinist and very amateur at 3D stuff. Although in college, way back when, I did take a couple of 3D animation classes. So at least I understand, X, Y, Z, and take a circle and extrude it, things like that. One thing that I wanted to do with this particular part here is I thought I would rapid prototype it and just do a 3D print. So the way I did this is there was an alignment pin on this disc, and I actually modeled it as a separate component, so I can turn that on and off right here. And the reason why is that I figured this hub, it's round, so I could make that on a lathe. I could surface it on a lathe, and then for drilling the holes, maybe I would do that on a mill. But I'm certainly not going to do, this shape sticking out like that off center of balance on a lathe. So I thought what I would try to do is essentially, however I would make this, I would follow the same process in 3D. So I actually sent this off to a friend as a 3D file, and then the pin as a 3D file. Had my friend print those out for me, and sure enough, they did actually pop right together, which was kind of exciting, especially since I was sort of just guessing at the tolerances between these two parts. And then, playing around with this, I thought, well, wait a minute, I don't have access to parts, even doing things like physically positioning the electric motor to the tractor. A little challenging, but what if I could just do this all on the computer? So let's take a look at the next part here. I have a 3D model of the tractor adapter plate. So essentially, this was already part of the tractor. This was a big metal plate that went onto the engine and the bell housing. And how did I get the 3D model of this? Well, I made it. And the way that I made it is right in the software, you can insert an image. In here it's called Insert Canvas. And what I did, and I actually rotated this all since I did the canvas, but if we take a look at the top view here of that adapter plate. So I literally just had it on the floor of my garage. I took a photo of it. I brought it into Photoshop. I deleted the concrete floor. Definitely makes this a little easier to work with right in the software here. And then what I did was I traced it into the program. You can do that with something called sketches. And let's see, that was sketch 2. And again, I've moved this since I did that. But here's the sketch. It's just a kind of a simple outline. I also measured the holes with my caliper and just sticking some drill bits through there. So we got 5/8 holes and 1/2 inch holes. And I just used the circle tool to mark where the center of those holes were based on the image. And then from there, I extruded it and I was able to make the part that we see on the screen now. And the other thing that I'm doing here is there's something in 3D space called the origin. And the origin is just where is the center of the universe. It's XYZ 000. For you nerds, it's more or less where Gallifrey is in Doctor Who. And I'm centering everything on this axis. And the reason why I'm doing that is I want everything to be perfectly centered so that when the flywheel is spinning, the hub is spinning, this plate, that everything is centered. So it's kind of like I'm designing this all on a virtual lathe. Everything needs to be concentric. Another really neat thing about this software is that you can bring in other types of parts. So up in Insert, right in the software, it has Insert McMaster Car Component. And when you click on there, it basically goes to their webpage, and there's all sorts of industrial stuff right there. Nuts and bolts and drive shafts and bearings and all sorts of really cool things. So I can just do a search for a bolt. And I know, for example, that I needed a 1/2 inch 20 bolt to go from this plate into the bell housing, and 1.5 inch long. And what's cool about this is you can get in and there's CAD files right in here. So if we go to the bottom, and I'm going to use a step file format, we just hit save and close, and it'll pop right into the project right here. And in fact, I already did that with some bolts. So let's take a look at those. I imported the one and then I duplicated it a bunch of times. So now we have these bolts that they perfectly fit those holes that I made for them. They are absolutely right size-wise. And I didn't have to 3D model them. I mean, that's kind of complicated to start 3D modeling, especially if you're using a whole bunch of different size bolts, for example. So these are the bolts that will hold this plate here into the engine. And if you've watched some of the other videos, those bolt holes are also where I had the rails bolted that I'm planning on holding the front end on with. So let's take a look at some of the other things that I want to do here. I figure I need some sort of a shaft to connect the hub back to the Nissan Leaf motor. And I just kind of put a kind of a placeholder in. Again, this was an off-the-shelf part that I just imported. This is a 1-inch drive shaft with a keyed, it's a keyed shaft right there. And that'll let me connect other things to it pretty straightforward. 1 inch, maybe I'll need to go a little bit bigger. Obviously, I want to make sure this is nice and sturdy, and I need some way to support it. So I did also bring in a bearing, and this is kind of a bearing I chose a little bit at random, but the idea is that the bearing will support the shaft, and that shaft supports the hub where the flywheel is. So all the weight of the flywheel is going to be going onto this bearing. Now, the other thing is that since there's going to be a flywheel here, it needs to be able to take some pressure as thrust when the clutch is pushed in. So I thought, okay, we need a better than standard bearing. There we go, right there. we can see that this is actually a taper bearing. So the whole idea is that it can take a radial load and it can also take a thrust load. Now, my understanding is that the style of bearing, it's kind of two parts, so you need something to hold it together. I'm not quite sure how I'm going to do that yet. This bearing is just kind of floating in space. I centered it on the plate, but it's not bolted in any way. If this was reality, it would be kind of flopping around a little bit. Now, how are we going to attach the electric motor? So I really want to use a Nissan Leaf electric motor with this project. I already have a Leaf motor, but we need to be able to attach it. Somebody else out there was using a Leaf motor. That was Jeff Black. He has a nice YouTube channel. Check it out. And he did a Mercedes with a Leaf motor. So he already had a file that he shared on his webpage. I just modified it a little bit. So this is my Leaf adapter plate for the moment. And the Nissan Leaf is a motor is a little bit weird shape. It's not just a plain cylinder. The outside edge is this kind of weird shape. So this plate matches that shape. And these outside edge holes line up with through bolt holes on the electric motor. These other holes, these are already here from the model that I imported. But now we can start to take a look at a few things. Like, I intentionally put this adapter plate out a little bit from the plate going to the bell housing here, because just based on the distance of, I'm going to have some sort of a coupler here that connects the Leaf motor to whatever I'm using as a shaft. And frankly, it's probably not going to be a stock shaft. I was thinking maybe on a lathe, I make this hub and this shaft all as one solid piece, so it's really nice and strong. Otherwise, I'm not sure exactly how I would attach this to a shaft and have it really with that high strength that we want for holding the drive line. But we're going to need a little bit of space out here anyways. The other thing, kind of important for a flywheel, is we want to make sure that the distance, keep in mind the face of this hub is the back of the flywheel, and we want to make sure that the flywheel is exactly where it was when it was held on by the engine. And one way of doing that is this plate goes on the front of the bell housing, and on the engine I can measure from the face of the crankshaft to the face of this plate as mounted on the engine. That was about 34 millimeters. So as long as I make sure that distance is still the same there, that'll put the flywheel back into the same plane, the same depth in the bell housing as it was originally. So as long as I maintain that relationship from here to here, we're good. And exactly where the electric motor goes doesn't really matter so much. I mean, it could be closer, it could be further, but it can only be so close just because of the drive shaft and whatever I end up using as a coupler. So let's take a look at how this plate would actually be mounted. We've got these nice holes on the outside here, and what I did in the 3D software, I've got it set up so that if I go to the front view, it's flat, there's no perspective. And basically I used the holes in the model of this plate to essentially project holes back into the red plate here that would be directly on the tractor bell housing. So now we've got some bolts, and again, pretty easy to just bring them in. I could just pull in those CAD files for bolts, so they're the right size, the threads are correct, they fit nicely through the holes here, and those would be able to go right through this plate, right through this plate, and into the electric motor, holding everything in place. Now I would have some spacers around them to keep them the right distance from our red bell housing plate right here. And now if we go back to the front view, we can see if we run into any issues, because this is kind of part of the joy of 3D now. I can look at this and see, for example, if there's any interference. Now here, the outside of the edge of the plate, it looks like it overlaps with this bolt, but keeping in mind that it's spaced out, that's not an issue. One thing that is an issue, though, is that the bell housing is hollow in the middle, and the outside thick edge has the holes for these bolts to thread into. Now, I didn't 3D model the bell housing because that would be kind of complicated. But one thing that I did notice was that if I get the right sketch, there we go, that's why we rename things. Essentially, the inside of the bell housing is just a circle, 7-inch radius, 14-inch diameter. So I just centered a 14-inch circle off of our central axis there. And now I can see essentially anything inside the circle is in the hollow of the bell housing. That's where the clutch, flywheel, all that stuff goes. But the outside of this is solid. That's that thick, flat edge where we can thread in these bolts. So now things get interesting. Like if we look at, for example, let's come up here. Boy, that bolt is really, really close to that edge. But if we actually select the bolt, I'll change my selection tool preference here. If we take a look at that bolt, it's not just that the thread is really close, but the head of the bolt, that would actually hit on that thick, solid part right there. So that's going to be trouble. That would actually interfere. I wouldn't be able to put it on like this. So just looking at the 3D space here, it's kind of neat that I can figure out things like that. So that's an issue. That's not going to work so well. So here is another approach. I don't necessarily need those bolts to be going right into the motor. Here the idea was I could use the same bolts to hold it from this plate to this plate and into the motor, but I don't necessarily have to do that. Let's try something different. I'm going to make these bolts disappear, and instead I'm going to do some other bolts. Okay, these are M10 bolts to the Leaf. So all I did was I turned off the visibility for those other bolts. So now, and these bolts are way too long because, you know, the motor is right in the front of this plate. I could just have some shorter bolts going through this adapter plate into the electric motor, and then I could have a different set of bolts hold this plate to here. And the way I would do that is, I mean, we already have some other bolt holes here. That seems like a lot of bolt holes. Maybe they're not the right size, but I could essentially just use those bolt holes, come on into the inside, and I think that would probably work just fine. Now, there's an issue with that too, though. You got to keep in mind that on this side of the plate, it's solid. The electric motor is going to be right there. So I could use these bolt holes, but only if I countersunk the holes to give enough depth for the bolt heads. They'd have to be countersunk, so this could still be flat. And I could do that. If this was a piece of thick aluminum, I could do it. But frankly, that sounds like more work. So a different way of doing it is I don't necessarily need this plate to be the exact shape of the Nissan Leaf motor. I mean, where these holes are, that's obviously important. But what's kind of neat here too is anywhere that we see this plate, that's where the motor is going to be. Anywhere on the outside of the circle we can't use because that's solid with the edge of the bell housing. But any of this other space between the two, there's no reason why we couldn't have the adapter plate for the Leaf motor being bigger, maybe it's just round, and put bolts, for example, here, 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 here. And the advantage of that is that we could bolt this part to the motor, and then after that, bolt this part to here. It'd be a lot easier to work on than if the bolts were on the inside, trapped behind the electric motor. So I think I like that approach better. We'll take this, we'll make it bigger, we'll put some bolts through here, and I'll do the same thing again where I'll design where I want the bolt holes to be, and then I'll essentially cast the bolt holes through into this plate. A couple other things we can do here too. through the Milwaukee Makerspace, there is a member who personally has a CNC plasma cutter. So maybe what I could do is, after I've got the holes in this plate, maybe I could visit him and export this CAD design straight to the plasma cutter and get a plate like this cut with a CNC plasma cutter. That would be very cool. Another possible option is maybe I could use my original plate and just cut fresh holes in it. I'd have to make sure that it's perfectly centered, be really careful doing my measurements, but I think that would work fine. Now there's one last thing that I want to talk about here, and that is hydraulics. So this has been one of the things that's been kind of challenging on this project, is that the hydraulics were driven by a hydraulic pump on the back end of the tractor. So essentially a tail shaft. Other things, the fan belt, the water pump, all of that was on the back side of the engine. The front side of the engine had the clutch for the transmission, and then also that kind of collar shaft for the PTO. So the single engine drove three different things, but one of them was on the back end. Now the Nissan Leaf motor does not have a tail shaft, so that makes this a little bit more challenging. There's a number of different ways I could do this. For example, I could use a forklift motor and hydraulic pump to independently drive the hydraulics. Big downside to that is my electric motor, the drive motor, and the pump motor would be running at different voltages. So now I need to have some DC to DC conversion going in there. It'd be a lot of current at 12 volts to run 10 horsepower of hydraulic pumping. So, I could go to 48 volts. Well, I'd need 4 12-volt batteries in there as a buffer, even with any sort of DC to DC conversion. So we're talking a lot of electrical design, voltage changes, and then space, physical mounting of the pump and the forklift motor. Forklift motor pump, it's like this big around, that tall. It's not insignificant. So I thought another approach would be to do this mechanically. So if we could somehow pull mechanical power off the single shaft of the Nissan Leaf motor, not necessarily a great solution either. I like that it's mechanical. Let's say in the future somebody else is working on doing maintenance on this tractor. If it was a mechanical solution, somebody else could look at it, go, oh, that's how that works, and they could replace a belt or a bearing, something like that. Whereas with a complicated electrical design, might be more difficult to troubleshoot, might be intimidating to somebody else. So let's take a look here at what I was thinking for doing, a mechanical output from this setup. So what I was thinking is, since these two parts, they're going to have to be spaced apart a little bit anyways, that means, in fact, there's a little bit of room in the middle here. And one option, a lot of people on some of the Facebook comments said, oh, you should do this or this or this. And some of them were kind of ridiculous, people saying, oh, just use the starter teeth on the flywheel, have that drive the hydraulic pump, which would be terribly loud and completely the wrong gear ratio. I don't know. People were throwing out a lot of crazy thoughts. One that was interesting was somebody said, why don't you could put a pulley on here and, mount the pump somewhere else. Now, the big issue with that, though, is one thing that you do not see in the 3D model is on the bottom of this, there's that bolster from the front of the tractor that meets right at the bottom here. And that's the part that lets the front axle go like this, going over hills, going over bumps, everything. That's important. And that bolts right there. It also helps connect the middle of the tractor to the front of the tractor. So I can't put a hydraulic pump down here. There's no room for it. Now, the other thing is I can't really put the hydraulic pump straight above, because that's where the inverter is going. And even if the inverter isn't going there, I'm kind of planning on batteries being right above this whole thing. And then if we've got those side rails mounted on the two sides, that means the electric motor is basically boxed in. There's no room anywhere in here on any direction for a hydraulic pump. But another issue that I had was after I've tested these rails from the Farmall H just being bolted on here, using those to connect to the front of the tractor, the issue with that was with that front bolster, that part that goes like that, I don't think there's enough clearance. There's some clearance, but it's only like that much. And you go over a big bump, you go over uneven ground, which is a tractor is an off-road vehicle. It's going to be going over uneven ground. If the rail is right here, this is going to boom, boom, boom like that. So a possible solution would be just simply to, instead of have these side rails right here, move them up. So maybe instead of these 4 bolts, maybe some sort of a custom rail goes to just these 2 bolts plus something else. And I think that can be fabricated. You know, I can put a plate across here that ties into these bolts at the top. There's a number of different ways that I could do it. And just raising those side rails will solve that clearance issue on the front with the front axle tilting back and forth. Now, what that can do also then is that means we've kind of freed up a little bit of space here. So I was thinking, what if we put a pulley on here and then mounted the hydraulic pump somewhere right down kind of around here, and with the same size pulley on it, and that would be a 1-to-1 ratio. Because keep in mind that pump originally ran at the exact same speed as the engine. So for example, we could have a pulley in here. Now this is just a simple V-belt pulley. Maybe I would want like a toothed pulley, like a timing belt style pulley. Might be another option. But if I have that pulley in there, come down to the pump, basically our drive shaft is going to spin with the electric motor, and then it will have the ability to draw some power off to run the pump. The pump will run the whole time the electric motor is spinning, which is exactly how it worked with the gas engine. And then on this side, we'll be spinning the flywheel, and that'll power the wheels to the ground, the transmission, and also the power takeoff. So that's kind of my thoughts in general right now. Let me show you one other thing on here. There's a lot of really, really cool features in this software. I mean, like, I could even pull up data telling you how much this assembly would weigh right now. There's just so many neat things in here. You can animate, you can create joints, all sorts of cool things. You can even export to like CNC routing systems, all sorts of neat things you can do in here. But let's go to animation. And I've got set up a simple animation here for you. Now, this is not real fancy animation. Typically, this is just to show how parts work, or maybe like an animated exploded diagram, how to build the thing. So right now you can see the shaft spinning. I've got a camera move so we can see both sides. So that's going to be the flywheel spinning around, powered by our shaft, powered by the Leaf motor. And inside here you can see that pulley spinning, and that'll power the hydraulic pump. One thing I'd have to still double check on here is that if I put the hydraulic pump there, that it does not interfere with the front end loader. The front end loader is a little bit of a funky shape. The side rails are kind of a big Z zigzag. But that's definitely one thing I'd want to check. I don't want to put this all together, go to put the front end loader on there, and it doesn't fit because there's a hydraulic pump in the way. Now I should be able to use the original pump hard lines, but what I'll have to do is cut the hard lines, shorten them, and then put a short bit of flexible hydraulic hose on there. So I hope this gives you some ideas about exactly how I'm trying to approach this project. It's felt slow lately, but at the same time, I am starting to get some of the mail order parts in. I did just get a device for controlling the Nissan Leaf motor. So you'll see in another video real soon that'll actually be spinning up the motor and talking about how that's going to be controlled. And I'm pretty excited about that. That's fun because mechanical design I'm not real confident about, but electrical stuff, that's a lot of fun, and I really get into that really fast. So I hope you like these videos. I know this one was a little longer, a little bit different, but I found it really interesting. And on any of the projects I've ever worked on, it's not just about the project, but it's also about the friends you make on the way, the skills you learn. You know, it's about learning batteries and electric motors. And in this case, hey, I'm learning a little bit of 3D mechanical design, which is pretty cool too. So I hope you like these videos. Please like, comment, subscribe, and until next time, stay charged up